Today, we'll be solving LeetCode 125, Valid Palindrome. This problem is a beginner-friendly classic, and it's one of those questions that shows up a lot in interviews to test your understanding of strings, loops, and basic logic. So let's break it down, step by step, and make it super easy to understand. Here's the problem. We're given a string, and we have to figure out whether it's a palindrome. Now remember, a palindrome is a word or phrase that reads the same forward and backward. But in this problem, there's a little twist. We're told to ignore all non-alphanumeric characters, and we should also treat uppercase and lowercase letters as the same. That means we skip over spaces, commas, punctuation, and we treat capital A and lowercase a as equal. Let's look at an example. In the first example, after we ignore the commas, colons, and spaces, and convert all the letters to lowercase, we see that it is the same forwards and backwards. So we return true. Now, for the second example, we see that it is not the same forwards and backwards. So that would return false. Now that we understand the problem, let's go over two ways to solve it. First, a simple brute force solution, and then a more optimized two-pointer technique. Let's start with the brute force method, which is simple and easy to write. We'll go through the string, filter out only the alphanumeric characters, convert everything to lowercase, and build a new string. Then we just check if that string is equal to its reverse. We start with an empty string called cleaned. This is where we'll store the valid characters from the original string. Then we loop through every character in the input string s. For each character, we check if it's alphanumeric using char.isalnum. This method returns true if the character is a letter or a number. If it's not, like a space or comma, we skip it. If it is alphanumeric, we add the lowercase version of the character to our cleaned string using char.lower. This way, we don't have to worry about upper or lowercase mismatches. Finally, we compare the cleaned string to its reverse using Python's slicing syntax, cleaned square brackets : (:1). If they're the same, we return true. Otherwise, we return false. This solution works great, but it builds a whole new string and takes extra space. Let's see how we can make it more efficient. We're going to optimize this using the two-pointer technique. This is a very common pattern that shows up in many string problems. The idea is simple. We place one pointer at the start of the string and one at the end. Then we move both pointers toward the middle while comparing the characters they point to. If at any point the characters don't match, we know it's not a palindrome. If all the valid characters match as we go inward, then the string is a valid palindrome. Here's the code for the two-pointer approach. Let's break this down step by step. First, we initialize two pointers. Left starts at the beginning of the string, and right starts at the end. We enter a while loop that continues as long as left is less than right. Inside the loop, we need to skip over any characters that aren't letters or digits. So we use s at left.isalnum to check if the character at the left pointer is alphanumeric. If it's not, we move the left pointer to the right. We do the same thing on the right side. If s at right.isalnum is false, we move the right pointer to the left. Once both pointers are pointing to valid characters, we compare them using s at left.lower and s at right.lower. This ensures the comparison is case insensitive. If at any point they don't match, we return false. Otherwise, we move both pointers inward and keep checking. If we make it through the entire loop without returning false, that means the string is a valid palindrome, so we return true. Let's quickly talk about time and space complexity. For the brute force solution, the time complexity is O(n) because we loop through the string to clean it and then reverse it. The space complexity is also O(n) because we create a new string. For the two-pointer solution, the time complexity is still O(n) since we examine each character once. But the space complexity is O(1) because we don't use any extra space as we work directly with the original string. So the two-pointer method is more efficient, especially when working with long strings. And that's how you solve LeetCode 125, Valid Palindrome. I hope you guys found this helpful. Thank you for watching, and let's keep learning.